In this first approach, to reduce duplicate events so we don't get the same file processed multiple times, we're going to make use of a dictionary. We're going to store the file names from the events as keys in the dictionary, and because a dictionary can't have duplicate keys, it will be impossible for the dictionary to have the same file name in it more than once at any given time. In this demo, we're going to be making use of a concurrent dictionary, which gives us a slightly different API than a normal generic dictionary. So what we want is a dictionary instance that's available within this console application and inside these event handler methods. Because we're working with top-level statements here, we can't actually add a static class-level field or property because the idea of the program class has been abstracted away, and effectively we're just working within a single main method in this program.cs file. So what we could do is we could convert this from top-level statements and revert to the more traditional console app where we have access to the program class to add a static field or property. But to save us from having to do that in this demo, what I'm actually going to do is come up and add a new class to our project here. I'm going to call this class FileSystemWatcher, just add that. And to save time, I'm just going to paste in this implementation. What we're doing here is defining a static class called FileSystemWatcher, which contains a static field of type ConcurrentDictionary. So this is just a quick way of giving us access to this concurrent dictionary anywhere in the code. We could of course go and refactor this to improve the design a little bit, but for the purposes of this demo, this will suffice. So this concurrent dictionary is a thread-safe dictionary that multiple threads can access at the same time if multiple files end up being processed at the same time. Let's come back to the program file here and we'll just scroll down to this file created event handler. What I'm going to do is remove this call to the process single file method, and in its place we're going to access the static files to process class, access the static files field here, and we're going to call the concurrent dictionary's try-add method. As with other dictionaries, we need to specify a key and a value. In this case, the key is the full path to the file name. We'll also use this as the value. We'll just copy this line of code, come down to the file changed method, and replace this call with a call to the try-add method of the concurrent dictionary, just as with the file created event handler. So now we have a dictionary containing unique file names that need processing. We actually need to loop through those files and start the processing for each one. What I'm going to do is come down here and we'll start off by deleting this process single file method because it's no longer being called, and instead we'll create a process files method. Inside this method, we're going to loop through all of the keys in the concurrent dictionary, and for each of the file names in the concurrent dictionary, we're going to try and remove that from the dictionary. This try-remove method attempts to remove and return the value with the specified key. If the key exists, the try-remove method will return true, otherwise this method will return false. The actual value comes from this output parameter, but because we don't need the value, we're just making use of this underscore discard. So if the file exists in the dictionary, it will be removed, and then the code inside this if statement will execute. All we need to do now is create the instance of our file processor and pass in the file name, and then call the process method as we've done in the past. So now we've got this process files method, it needs to be called periodically to process files in the dictionary. To do this, what I'm going to do is come up here, and just after we create the FileSystemWatcher instance, I'm also going to create an instance of a timer. This timer will execute every 1000 milliseconds, and every time the timer executes, it will call the process files method that we just created. Notice we've got this red error here because the method that this timer calls needs to have a specific signature. So what we'll do, come back down here and just add this state info object parameter to satisfy the timer. Let's just build this to check we haven't introduced any errors, and the build succeeds. Before we run this version, we're going to clean up the input directories, just going to delete, backup and complete. And what we're going to do is, as before, we're going to take a copy of data1.txt, paste it into the input directory before we go and run the application. We'll go and modify this file using WordPad as we've done before. And let's go and save these changes. And we can see in the console application, as before, we've got two changed events for data1.txt, but we've only attempted to process the file once. Let's go and try and run another file. This time we'll choose data2.txt. We'll just paste that to the input directory. And we can see here we've got the created event and data2.txt processes as expected. Let's just hit enter to return to Visual Studio. There is a small chance for a potential bug here, however. Notice here we're calling the process method every second. In theory, it's possible, depending on the timing of events, that we could get one of the FileSystemWatcher events occur just before this 1 second interval. The process files method executes and removes it from the dictionary, and then a second FileSystemWatcher event occurs for the same file. Because the dictionary now doesn't have the file name in it, it will be added again, and the next time the timer executes, it will be processed a second time. You could of course modify this approach and use a dictionary to store the file names of files that have already been processed and only process a file if it's not in that dictionary. If you took this approach, however, you may need to run a process to remove older entries so your app doesn't continue to increase its memory usage. Let's take a look next at another implementation, this time one that uses caching.